In this video, we will discuss the chi-square goodness of fit hypothesis test, and we will be using equal frequencies to do this. Let's start by looking at the requirements for this hypothesis test. First of all, our variable must be qualitative, which means that it is the name of a category. Second, we will be testing to determine whether different populations share the same frequency. This test in many textbooks is called the test of homogeneity, and basically we are testing to see if these different populations are homogeneous or the same. In this test, random samples will come from different populations. Now remember, normally when we perform a hypothesis test, we use a random sample from a single population. Next, let's look at the hypotheses for this type of a test. First of all, the null hypothesis will say that the variable occurs with equal frequency. The alternative hypothesis will state that the variable does not occur with equal frequency. You see a bowl of M&Ms on the side. One of the most frequently used examples for this hypothesis test is to determine whether the different colors of the M&Ms occur with the same frequency. Meaning, do I have the same number of red, yellow, blue, green, brown M&Ms in my population? Or do I have one color that appears more frequently than the others? We're going to use a different example, however, to perform our analysis in StatDisk. I have 254 baseball fans, and they were asked what their zodiac sign is. The results from this poll are given in the table below, and what we want to test is whether the zodiac signs are evenly distributed across the population, and we're going to use a level of significance of 0.01 to do this. We would start by analyzing this scenario to make sure that the goodness of fit equal frequencies test can be used. First of all, the variable of interest is zodiac signs, and that is qualitative because it consists of categories like Leo, Gemini, Pisces. So those are just names. We are testing to determine if the frequency of these zodiac signs is the same. And we have random samples that are actually taken from different populations, and those different populations are the zodiac signs in a given year. So we have determined that we can use the chi-square goodness of fit equal frequencies to do this test. We will start by doing the null and alternative hypotheses. For this scenario, the null hypothesis would be zodiac signs occur with the same frequency throughout the year. The alternative hypothesis would be that zodiac signs do not occur with the same frequency throughout the year. Once we have the hypotheses, we can go into StatDisk and actually perform the hypothesis test. Remember that StatDisk always opens with the sample editor in order for us to put in our data. So I entered the frequencies from our table given earlier into column 1, and I labeled it zodiac frequencies. Once we have the data entered, we can perform the hypothesis test. So at the top of the StatDisk menu, we would click Analysis. At the pull-down menu, we would choose Goodness of Fit, and then choose Equal Frequencies. Once you've done that, the left-hand side of this menu will appear. And what we will need to do is to check the significance level and enter the column where our frequencies were entered. So the level of significance for StatDisk, remember, defaulted to 0.05. So we would need to change that to 0.01. And then we would need to choose the column where our frequencies were entered, and that was column 1. So I chose that. At this point, we can click Evaluate, and you will get the results of your test populated on the right-hand side of this menu. Notice that the p-value is 0.9119, and we will need that information to write our conclusion statement. Recall that the conclusion statement has a prescribed format. First of all, you have a comparison of the p-value and the level of significance. Second, you state whether the null hypothesis is rejected or not. And last, you provide a synopsis of the hypothesis that is supported by the data. Given that, we would have a conclusion statement of, since the p-value of 0.9119 is greater than the level of significance of 0.01, the null hypothesis is not rejected. Therefore, the data supports that the zodiac signs do occur with the same frequency throughout the year.